Hello everyone, this is Zhongzhi Chen from Alibaba Cloud database team. I'm the engineer director of RDS team. Today my topic is ApsaraDB RDS service, achieving effortless scale for everyday applications. So let's quick through today's content. The first part is overview of ApsaraDB RDS in AI area. And then the second part, I will introduce the architecture and the tech behind the RDS service. The third part, I will show you 4 common use cases of RDS service. And then the last part, I'm show you some demo of ApsaraDB RDS service. Let's beginning. This is a big picture of ApsaraDB RDS in AI area. Let's start from the upbound. The first part is database service. RDS, we have 4 database products. The first part is RDS for MySQL, RDS for MariaDB, and RDS for SQL Server, and RDS for Postgres. In this year, we add a new backend as service in RDS. That is Superbase on RDS, and then the Superbase will communicate with Qianwen. In the second part, that's the data storage part. In the previous years, we only have node-based storage engine, such as in MySQL, there is InnoDB, and in Postgres, there is also a load-based storage engine in Postgres. And in this year, we add a new column-based storage engine called DuckDB in MySQL and in Postgres. And we also add vector-based storage in our product. In Postgres, we use pgvector, and in RDS MySQL and in RDS MariaDB, we add our own vector-based storage engine. And in the hardware, we not only have CPU, we also have GPU instance. And specified to storage hardware, we add a customer storage hardware for complex. So if you have large data in the disk, we can use customer complex disk to store the data. We can have a nice compression radio to save your money. So our RDS team has supporting Alibaba economy system for more than 10 years. We have supported the Double 11 festival in Alibaba. And in the 2024, Alibaba Cloud has cooperated with Olympic Games in Paris, and our RDS SQL Server has supported the solution multi-region disaster recovery system in Paris. So let's start today's technical part and ApsaraDB RDS service, the architecture and the tech behind the RDS service. Before RDS service, let's first start the challenge of latency database. You can see from the left picture, and the green line is the resource specification, and the orange line is the workload. So at the beginning, there is resource provision for the workload. There you may waste some of the CPU and the memory. And in the middle part, there is insufficient resource. That may cause your workload down. So next conclusion, there's 4 panes in the latency database. The first part is higher TCO due to waste resource. Traditional database will require fixed capability planning, lead to paying for the idle resource during low traffic period, and it need to manual scaling delay due to unaccepted spike, such as in this picture. And then the second pane is lost revenue and degrade user experience, such as in the sudden traffic surges. This can cause downtime due to slow scaling and require pre-purchase reserve instance. And then the third pane is increased DevOps overhead and slow time to market. That require manual scaling, backup, and restore setup, and performance tuning, such as add indexing and partition. And then the fourth part is slower iteration cycle and high test cost. The non-serverless database will require static DB and test environment, and yes, struggle with ephemeral workload such as CI/CD pipelines. So why use ApsaraDB RDS service? You can see from the picture, The green line is the service resource elasticity, and the orange line is the workload. You can see the difference from this picture and then the preview picture is that the service resource elasticity is follow with the workload. So if the workload up, and then the service resource will going up, and then if the workload down, the service resource elastic will down. So you don't waste any resource. It is extremely elasticity, and it is pay as you go. And so the service is operated by the RDS instance. You don't need to operate the instance. So it is easy to operate and manage. So in this picture, you can see there's up to 19% cost saving. The resource adjustment in second based on customer workload, business stability guarantee, and there's no business interrupt. It is smooth scaling up and scaling down. The storage are scaled as well. So it is charged by RCU instead of traditional CPU and memory. The 1 RCU is equal to 1 vCPU and 2 GB memory. So let's highlight the ApsaraDB RDS service. It is cloud native. It will separate the billing for computer and the storage, and it is stateless computer and easy scaling for scaling, and it enhanced service for secure storage. And the second part is auto elastic scaling. No manual operation is required for the scaling, and it is intelligent machine learning based scaling. It will scaling according to your workload, and it adaptive CPU, RAM, and storage scaling. It is pay per use. If your instance don't scaling up and down, the billing is just as normal. The billing cycle is accurate to milliseconds, and pay only for what you use. No cost for idle computer resource. The price model is RCU, RDS capability unit as computer unit. As we said before, 1 RCU is equal to 1 vCPU and 2 GB. And then the minimum RCU granularity is 0.5 RCU. The storage is same as the regular RDS instance. The billing is second and the millisecond level. Bills will generate per hours. Let's show you the design of ApsaraDB RDS service. In the computer layer, we will support buffer instance online resize. In the MySQL instance, in the preview 8.0 version, the buffer cannot online resize. And even in the 8.0 version, when the MySQL instance resize the buffer, it may cause the instance to hang for some while. So we support online buffer resize to avoid the hang when we resize the buffer. And in the storage layer, we decouple the I/O performance and the capability up to 1 million IOPS and 4 GB bandwidth. We dynamically increase I/O up limit according to the actual usage. We call it I/O burst. So even if you only have small size of disk, you can up to 1 million IOPS. And we support two types of service. The first type is pure service. The resource will elect. We support two kinds of service. The first is pure service. It is elastic scaling with the load. You can see from the picture, the resource usage is follow with the workload. And then the second part is the isolate service, local, elastic, scaling fast and more stable. In the following picture, you can see that the instance will scaling up more quickly. We upgrade the pure service to isolate service. In the isolate service, we can confirm that the 99% of the instance scaling up in the local instance. We achieve this by reserve some CPU and some memory in our local machine. And we can confirm the local elastic scaling faster and more stable. So the latest part of ApsaraDB RDS service capability, it is more elastic, enhanced elasticity upper limit. This is the latest ApsaraDB RDS service capability. The basic version is the provision service. You can upgrade to high availability version service and provision. There is more elastic, enhanced elasticity up limit. The maximum support for 32 RCU, and then the premium ESSD maximum IOPS to 1 million, and then the throughput is 4 GB. It will have more flexible multi-form fusion, support upgrading serverless instance from basic version to high availability version, and support provision and serverless mutual conversion. The instance endpoint VIP DNS remain unchanged. Application is unaware, no need to modify your application. It is more stable, anti-GT electricity, no GT for CPU memory during scaling, no business interrupt, fast and cold startup and resume after pausing instance, smooth database kernel upgrade. This is the tech behind ApsaraDB RDS service. There's two control, the local control and then the second control. The database kernel will perform matrix connection to the data connection model. The data connection model connects the data and then aggregate the data to the decision model. And then the decision model will make choice where to scale up, down. If we make scale up, it will notify the central cloud native scaling, and it also to make decision to scale up or down the instance. Then we'll send the parameter change to the instance. And you can see that the decision model will notify the cloud native scaling and notify the instance kernel in parallel. So the local scaling capability will scale up in 5 seconds and scale down in 15 seconds. Let's show how RDS service doing cross-machine service. The first three steps is the same. It is different in the third part in the decision model. When there is not enough resource in the local machine, the RDS service will doing cross-machine scaling. You can see from the picture that in the left MySQL instance, there's not enough resource. So we will service from the old machine MySQL to a new MySQL in a new instance. So there's different from local machine scaling is in the decision model. The decision model finds that there's not enough resource in the local machine. So it will notify to the central decision. And then the central decision receives the message that there's not enough resource in the local machine. So it will to do cross-machine resource. And then the central schedule model receives the message that we need to do a cross-machine scaling. So it will find a machine with enough resource to doing the cross-machine scaling. And when we doing the cross-machine scaling, we have to do some work in our process model. In our process, we can persistent the connection, and then the router section will hold up to 50 seconds. And then the RDS service also support auto start and stop. When auto start and stop is enabled, if no connection is not available for more than 10 minutes, the compute node will automatically pause. Thus, only storage costs are incurred during the time. In the third part, let me show you some typical scenario of RDS service. The first part is the most general usage and the test environment usage, because the test environment is low frequency load and no core business scenario. If you use the provision instance, you may waste some resource. So you can use the RDS service in your test environment and use the provision version in your production environment. And we can find the second most usage is the disaster recovery environment. So such as in your IDC or your normal instance, it is a provision instance, and you want to support a disaster recovery. So you can add a RDS service instance in another region. Before, if nothing happen or you write less data, the RDS, the service RDS instance only use such as 2 RCU. It save a lot of resource. And when there's an accident happen, you can switch from your IDC instance or your another region instance to the service RDS instance. when your RDS service instance gets the traffic, the instance will scale up from 2 RCU to 16 RCU or more RCUs. And the third usage is the audio and the video compression transcoding with FC compute. We can see some usage in the FC computer. And then the fourth usage is the multiplayer online collaborative office with FC compute. Let me introduce the disaster recovery solution of ApsaraDB RDS for financial scenario. You can see from the picture the service disaster recovery architecture. The solution is using RDS service to achieve real-time disaster recovery combined with its adaptive scaling. This new architecture optimizes both cost and business risk. The results that compared with the traditional RDS, it can save more than 70% of the cost. The first benefit is the business continuity, low RPO and RTO issue, real-time data synchronization between the product environment and the disaster recovery environment to support disaster recovery at any time. The faster disaster recovery to service RDS once IDC failed. Service RDS can automatically scale in seconds. RDS service, it is low cost, no need to pre-provision the redundant resource, less resource cost, and it is pay as use, low one-time investment required, and it only pay for the resource consumed during daily usage, low charge applied during the idle periods. And then the data is security. The data synchronization channel is a dedicated data transmission channel, and then the cloud is encryption, and then the backup in instance. So the last part is the demo part. Let me show you the demo of using ApsaraDB RDS service.
In this demo, we will showcase the real-time elasticity of serverless ApsaraDB RDS. On the left, we're monitoring the resource utilization of our serverless instance. On the right, a load test script will run, gradually increasing and decreasing the database pressure. Let's begin by applying pressure. As the load increases, watch the CPU and memory usage rise, triggering an immediate response in RCU's RDS capacity units. As we continue, all metrics, CPU, memory, and RCUs continue to adjust. Notice how the InnoDB buffer pool size also scales automatically to optimize performance. The system scales up adaptively until it reaches our pre-configured RCU limit. Now, let's gradually reduce the load. CPU and memory drop instantly, while the RCUs scale down smoothly to ensure service stability. Throughout this entire process, there is no service degradation or interruption. Next, we'll simulate an unexpected traffic spike. We will pause the pressure test for a moment before initiating a new high-pressure test to simulate unpredictable traffic. Alright, it's time to run the high-pressure test script. Triggering the high-pressure test now and watch as the RCUs instantly scale to the maximum specification to handle the surge. Finally, once we stop the pressure test, all metrics quickly return to their original state. The instance scales back down to its baseline of 0.5 RCU, demonstrating perfect cost efficiency.
So that's the demo. Your next step is try RDS service with 15% of promotion. You can buy the ApsaraDB RDS for MySQL service and ApsaraDB RDS for Postgres service. That's all. Thank you for listening. See you.